So hello dear students, welcome to this YouTube channel, and today we are going to start some basic concepts of chemistry part 2. And those who have not watched the part 1 of this video, do watch that one first. Okay, so in this bridge course, as I told, we are going to cover everything which is required for the basics of the chemistry, right? So let's move on. So in this session we are going to learn about what is atomic mass and what is molecular masses, and also about mole concept, okay, and then about percentage composition we are going to learn. So basically, what is atom? Before we move on to atomic mass or molecular mass, we must know what is atom and what is atomic mass, right? So atom is this small particle. Atom is this small particle that cannot be seen and isolated. What they are saying, atom is a smallest particle that cannot be seen. Generally, in the part 1 we have discussed about matter, right? So in every matter we know that there is a atoms, there is a molecules, right? So atom is the simplest unit present. Okay, so atom is the smallest particle present in any matter. But can we see the atom? No, we can't able to see the atoms, and even we can't able to isolate it. What is the meaning of isolate? Isolate means we can't remove an atom from the matter. Clear? Therefore, it is impossible to determine the actual mass of single atom by weighing it. What it is saying? We can't able to determine the mass of one single atom. Why? Because it is very small and we can't able to isolate it. Okay, so this is a kind of problem, right? If you want to find the mass, how can we do that? But today's scenario, in present scenario, we have a mass spectroscopy. Using mass spectroscopy, we can find the atomic mass. But earlier means a very years ago, okay, at that time it was difficult for us to find out the atomic mass. So Avogadro hypothesis helped in this part. Okay, what is Avogadro hypothesis? Avogadro hypothesis finally solved this problem. He took equal volume of two different gases under similar conditions of temperature and pressure, then he weighed them. This is in case of gases only. Okay, Avogadro hypothesis. We have already learned about Avogadro law in the previous video, right? What is Avogadro law says? I have a same container, okay, equal volume. In this, the gases are filled. Any gases, different gases, okay. Let us take any X named gas and Y named gas, or else you can take nitrogen gas here and oxygen gas here. Okay, later on what we observe that the number of particles in both are going to be equal. Even though they are different gases, the number of particles are going to be equal. This is what said by the Avogadro. Clear? When I have the condition is temperature and pressure is similar. In both the cases, we have to keep temperature and pressure equal. Okay. So carbon is taken as a reference for determination of atomic mass. Carbon is taken as reference for the determination of atomic mass. So earlier, when we didn't had an idea about atomic mass, earlier hydrogen was kept as a reference to find out the mass of atom. Okay, to find out the atomic mass, hydrogen was taken as a reference because it was the smallest element present, right? But later on, we took carbon as a reference to determine the atomic masses. Why? We must know the reason, right? So carbon is taken as a reference because in every way, in our food, in our environment, wherever we see, the carbon is occupying the largest portion. Wherever we see, the carbon is occupying the largest portion, means carbon is present in abundant. Okay, so carbon is taken as a reference. Okay, now let's learn. Get this one here. Okay. Atomic mass. What is atomic mass? Atomic mass is defined as a mass exactly equal to 1/12 of mass of one atom of carbon-12 isotope. It is defined as mass exactly equal to 1/12 the mass of one atom of carbon-12 isotope. This is what the atomic mass definition. But we must know why, right? We'll learn why, how we have said this, right? So let's move on. Atomic mass. Mass of one carbon atom, carbon-12 atom, is equal to 12 AMU. How do we got to know this is 12 AMU? Because in the carbon we have 6 protons and 6 neutrons, correct? So we call it as its atomic mass is going to be 12. Okay, so atomic mass of carbon-12, one atom, is known as 12 AMU. What is this AMU, you can ask, right? AMU means atomic mass unit. Or it can also be written in place of AMU, somewhere you can see U also. U means unified mass. What it means? Unified mass. Okay, unified mass. So when I have a mass of one carbon-12 atom which is equal to 12 AMU, then what is 1 AMU? Simple thing. What we have to do? I have to take this number to the denominator. So what I am going to get? 1/12 into mass of one carbon-12 atom. Clear? Okay. So this is very important. This is very important. Finding value of AMU in grams. Let's solve this. Okay. We got a atomic mass in terms of atomic mass unit. But if I want to find out in terms of grams, what I have to do? We'll do it here and we'll see how we can solve. Okay. So as we know that in the carbon there are 6 protons and 6 neutrons, and even we have electrons. But electron's mass is very small, so we can neglect the mass of electron. Okay. So let us find the mass of carbon-12 atom. Okay. So in the carbon-12 atom, one carbon-12 atom, we know that we have 6 protons. So 6 into mass of proton plus 6 into mass of neutron. So we know that mass of neutron is equal to mass of proton. So I can write this as 12 into mass of proton. Okay. So what is the value of mass of proton? 1.66 into 10 power minus 24. Correct? So this is in terms of gram. So if I write this one, 12 into 1.66 into 10 power minus 24 gram. This is mass of one carbon-12 atom. I know that mass of one carbon-12 is equal to 12 AMU, right? So I can, in place of this, can I write 12 AMU? Yes, I can write. So if I want to find the value of 1 AMU in terms of gram, what I'm going to do? I'm just taking this 12 in the denominator. 12 into 1.66 into 10 power 24 divided by 12. So if I solve this, I'm going to get the same value. What is this? 0.66 into 10 power minus 24 gram. So what I got to know now? One atomic mass unit is equal to these. That is the mass of proton or neutron value. Correct? Okay. Now, okay, average atomic mass. In the average atomic mass, why do we need to find out average atomic mass? That is the first question arises, right? So why average? Because most of the elements exist also in the isotopic form. So you may ask, ma'am, what is isotopes? You know the definition. What is isotopes? The elements which have same atomic number but different atomic mass number. Correct? So in case of carbon atom, carbon element exists in 3 isotopic form. One is carbon-12, another carbon-13, another carbon-14. So carbon exists in 3 isotopes. Okay. So if I want to find the average atomic mass, what I have to do? I have to take the average of all the three. Generally, you have learned about averaging in the maths, right? How do we average? We just take the add up all that value and divide by number of that, right? Similarly, we are going to do here. So we have a formula here, average atomic mass. Summation of percentage of abundance into mass number divided by 100. So if I want to find out the average atomic mass of carbon, what I have to do? Simple thing. Percentage abundance of all these three. Let's take 98.892 into mass number 12 plus 1.0108 into 13. Okay, plus 2 into 10 power minus 10 into 14. I'm going to add up all these three and divide all those by 100. Then if I solve this, I'm going to get a value equals to 12.01 U, or I can say AMU. Okay, this is the average atomic mass of carbon atom. Clear? So similarly, there are many elements which exist in the isotopic form. So with that, we can find out the average atomic mass. Now let's learn what is gram atomic mass. Gram. Atomic mass measured in terms of grams is known as gram atomic mass. A very simple thing, right? So we'll see this. The atomic masses of elements expressed in grams is their gram atomic mass. Simple. The atomic masses of elements expressed in grams is known as is their gram atomic mass. See, very simple. See, the atomic mass of oxygen is 16 AMU. 16 AMU. But if I want a gram atomic mass, what I have to write? The same thing, but in place of AMU, I am going to write gram. Then you can ask me, ma'am, what is the difference between AMU and gram? There is a very huge difference. Let us see what is that difference. See, just now I told 1 AMU is equal to, what is that value? 1.66 into 10 power minus 24 gram. Okay, this is 1. And versus if I put 1 gram, 1 AMU and 1 gram. I'm just taking the difference. What is the difference? See, minus 24 means what? That many zeros I have to write in front of this particular number. That much negative value means there is a very huge difference. If a gram is of this size, the this gram is going to be a very small. There is incomparable differences there, right? So AMU and gram is completely different, but the numerical here I have is same. Okay, if I want to express the atomic mass in terms of grams, I am going to write the same thing, but in place of AMU I am going to write gram. Very simple thing, right? Okay. Now let's learn about molecular mass. So what is molecule? When atoms combine, we get molecule. See, hydrogen is an atom. Another hydrogen atom I have taken. I combined it. I got H2. What is this H2 now? It is a molecule. Okay. This hydrogen atom and this hydrogen atom, when they combined, I got a hydrogen molecule. So if I want to find out the molecular mass, what I have to do? I have to weigh the molecule, right? I should get the mass of that molecule. Very simple. The sum of atomic masses of all the atoms present in a molecule is known as molecular mass. Let me take this one down. Okay. Sum of atomic masses of all atoms present in a molecule is known as molecular mass. Simple. See, let's take an example. Here itself they have given example. We'll take one more example. Consider nitrogen gas. Okay. Any molecule. Let us take we'll take oxygen only. Okay. And the oxygen, it is molecule or atom? It is a molecule. Why it is a molecule? Because I can see two atoms combined and I got an oxygen molecule. Okay. So if I want to find the molecular mass, what I have to do? I have to add the atomic masses of two oxygen. Right? That is only what they do. And what is gram atomic mass? So what is mass of molecule generally? The mass of molecule is atomic mass of oxygen atom is what? 16. 16. Correct. So I have two oxygen atoms. So 16 into 2, 32. Correct? 32 AMU. But if I want gram atomic mass, what I am going to do? Just I will write in place of AMU, I am going to write gram. That's it. If I want to find the gram or molecular mass, what I am going to do? In place of AMU, I am going to write gram. Simple. The molecular mass of substance expressed in grams is known as gram molecular mass. Molecular mass of oxygen is 32 unit unified mass, and gram molecular mass of oxygen is 32 grams. Simple. Okay. Formula mass. What is formula mass? Generally, you got a difference between atomic mass and molecular mass. But what is this new thing? We don't know, ma'am. Okay. Formula mass. Formula mass is generally a mass. Formula mass is generally used for ionic compounds. Okay. We use this for ionic compounds. What is this ionic compound? Ionic compound means a compound which should have ions. Simple thing. I'll give you an example. NaCl. What is NaCl? A common salt which we use every day. We used to consume, right? So in NaCl, we have Na plus ion and Cl minus ion. So these two are ions, right? So it is become an ionic compound. Okay. Similarly, can you give any other example? Yes, Mg, magnesium chloride. Okay. Or okay. So there are many more examples you can think of. Okay. It is sum of atomic masses of all the atoms present in formula unit of a compound. Same thing as we were doing for molecular mass, we have to do it here. Okay. This is generally used for ionic compound. Okay. NaCl. Atomic mass of Na plus atomic mass of Cl. What is the atomic mass of Na? 23. And what is the atomic mass of Cl? 35.5. So if I add this, I am going to get 58.5 U. Okay. So this is not expressed in gram. Do remember that. This is not expressed in gram. This is expressed in U or AMU. Okay. Simple. Now let's solve some of our problems. We are going to calculate the molecular mass of some of our compounds here. Okay. So methane. What is methane? CH4. Right? So in the methane, I have one carbon atom. So what is the atomic mass of carbon? It is 12. I'm going to write down here. Carbon 12. Hydrogen 1. Okay. Oxygen 16. Then Na 23. Cl 35.5. Now you can easily solve. Right? One carbon I have, so 1 into 12 plus 4 hydrogen I have, 4 into how, what is the atomic mass of hydrogen? 1. So if I solve this, 12 plus 4, 16, right? 16 U. But if they ask you gram molecular mass, then you are going to write 16 gram. Simple. Okay. For H2 we are going to solve. H2. hydrogen. How many hydrogen we have? 2 hydrogen. Okay, and 1 oxygen we have, that is 16. So 16 plus 2, 18 U. Third one, CO2. Carbon 12 plus 2 oxygen we have. Oxygen is 16. Okay, 12 plus 16 2s are 32. Okay, so 4, 3, 44 U. 44 U. They look same. Okay. NaCl we have already solved in the previous. Okay, no problem. We will solve it again. Na23 plus 35.5. 58.5. Okay. So now let's move on to a very important concept that is known as mole concept, which is a very interesting topic, okay, and which is very important for you to learn. Okay, so what is mole concept? So this mole concept is a concept which is introduced to simplify the thing. Consider you went to a market, okay, and you asked a vendor to give one piece of banana. Is he ready to give one banana? No, he is going to ask you one dozen you want, 2 dozen you want, 3 dozen, how many dozens you want. So why this dozen? Why he is calling the dozen? Because 1 dozen is equal to 12 pieces. He is going to sell 12 pieces together. He is not going to sell one bananas, right? So similar thing applies here. The mole concept is introduced because in the matter there are many more atoms or particles are present. To simplify this thing, he made that the Avogadro number, that number is equal to 1 mole. But you may ask, why ma'am? Why does this 1 mole is considered as this many particles only? Why not any simple number we can keep, right? But there is a reason behind this. So let us know how this number came. Okay, so this number is known as Avogadro number, which is denoted by Na. So one more thing, if I ask you to bring 1 mole of pen, what does it mean? It means you have to bring these many number of pen. Similarly, if I speak about 1 mole of atom, you are going to say these many number of atoms. If I speak about 1 mole of molecules, then you must know these number of molecules. Are you getting? Okay. So let us learn how this number introduced. So generally we know that carbon 12 is the atom which is taken as reference to find out the atomic mass. Right. So what we considered is, we considered 1 mole is equal to 12 gram of carbon 12 atoms. 1 mole is equal to 12 gram of carbon 12 atoms. So what is the mass of 1 carbon 12 atom? We must know that, right? So mass of 1 carbon 12 atom, how can we find out? See, 1 carbon 12 atom mass we have to find out, right? Mass of 1 carbon 12 atom. So we know that in the carbon we have 6 protons and 6 neutrons and even electrons present, but the mass of electrons is negligible. You can neglect that because it is very small. Okay, so if I want to find out the mass of 1 atom of carbon 12, what I have to do? I have to take the mass of proton and neutron, right? So what I will do? 6 into mass of proton plus 6 into mass of neutron. So I know the mass of proton and neutron. Mass of proton and mass of neutron is equal, and it is equal to 1.66 into 10 power minus 24. This is something I know that. We know that. So what I am going to do? I will simply put 12 into this number. Why 12? Because mass of proton and mass of neutron is exactly equal, right? So I can take it as 12. 12 into 1.66 into 10 power minus 24. Okay, grams. This is the mass of 1 carbon 12 atom. Okay, here you can see the same thing I have written here. 12 into 1.66 into 10 power minus, this should come here. Okay, 24 gram. Then if I want to find the 12 gram, what I have to do? This is for 1 atomic mass. Mass of 1 atom of carbon 12. But what about 12 gram of carbon 12? 12 gram. So what I will do? I will keep this 12 grams here itself. I am going to shift this number to that side. So mass of 1. Okay. I will do it here itself. Okay. So mass of 1, if I want to find out the 12 gram is equal to how many atoms, 12 gram is equal to how many atoms, what I will do? 12 gram is equal to 1 divided by this number, right? So 12 gram, I am just keeping this 12 gram this side and I am taking this to here. Okay, 1.66 into 10 power minus 24. Okay, and if I solve this of atoms, and if I solve this, I am going to get this number, that is 6.022 into 10 power minus 24. Okay, not minus 23, is 23 plus 23 atoms. Which atoms? Atoms of carbon 12. Clear? So here you can see I have written here, in 12 gram of carbon 12 atom we have these number of atoms or entities we can call. And we know that we call 12 gram of carbon 12 atoms equals to 1 mole. So we concluded that 1 mole is equal to, so we concluded as 1 mole is equal to these number of atoms or entities. Clear? You got a clear idea what is this. So you have to remember that 1 mole is equal to how many particles? Avogadro number of particles. What is Avogadro number? This is Avogadro number. This is Avogadro number. Okay. Simple. And 1 mole is equal to 12 gram of carbon 12 atoms. You must know this also. 1 mole is equal to 12 gram. It's not 1 gram. It's 12 gram of carbon 12 atoms is equal to 1 mole. Okay. Fine. Now we'll move on to our next concept, that is percentage composition, which is very simple. If you are good in maths, this is very simple. Fine. What is percentage composition? It is a percentage by mass of each element in a compound. So you just see the formula here. Later on we are going to solve the problems. In that, this concept is going to be clear. Okay. It is a percentage by mass of each element in a compound. Consider I have a compound known as water. In this, if I want to find out the percentage of hydrogen present, percentage of oxygen present, then finding this is known as percentage composition. Simple. Simple, very simple. In any compound, the elements present, the atoms present, if I want to find out the percentage of each element in that compound is known as percentage composition. So see, let us see the formula. Mass percentage of any atom, of an atom. Number of atom of that element. Consider if I want to find out the mass percentage of hydrogen. What I am going to do? Number of atom of elements in this. How many number of hydrogen present? 2. So I will write 2. Atomic mass of element. What is the atomic mass of hydrogen? Into 1. Okay, because atomic mass of hydrogen is 1 into 100. Already they have given. Divided by molecular mass of compound. Divided by, what I have to do here? Molecular mass of compound. What is the molecular mass? What is the formula? We have already learned how to find molecular mass, right? Sum of atomic masses, right? So 2 into 1 plus oxygen has the atomic mass of 16. So 16 plus 2, 18. So molecular mass is 18U. So what I will write here? 18. And if I solve this, that is 2 into 1 into 100, divided by 18. I'm going to get the percentage of hydrogen present in this particular compound. Simple. Similarly, we are going to find the percentage of hydrogen. So this formula is going to be very important. Okay, now let's solve the problem. If you solve the problem, you will get the clear idea. You are not going to have any doubts, right? So Na2CO3, Na2CO3. So let us see the atomic masses first. Sodium 23, carbon 12, oxygen 16. These are the atomic masses. So now if I want to find out the percentage of sodium, what I have to do? How many number of sodium atom present? 2. What is the atomic mass of sodium? 23 into 100, because we are finding a percentage. So we are multiplying 100 divided by its molecular mass. What is the molecular mass of this? Molecular mass of Na2CO3 is Na 2 into 23 plus carbon 1 atom, so 3 into 16. If you solve this, you need to solve this. Okay, if you are going to solve this, if you're going to solve Na2, okay, if we solve this, we are going to get somewhat a value, right? What is that? 2 to the 6, 2 to the 4 plus 12 plus 48. If you are going to solve this through all the number, 10, 16, 4, 5, 8, 9, 106. Okay. I got the molecular mass equals to 106 gram. So to find out the percentage of sodium, what I am going to do, I am going to write this number here, and if we solve this, we are going to get the value of percentage of sodium in this compound. How we can solve? That is 2 into 23 into 100. Okay, divided by 106. So you got somewhat 43.39%. Similarly, if we want to find out percentage of carbon, how we can solve? Simple. How many carbon atom we have now? 1 carbon atom. Okay. What is the atomic mass? 12 divided by 106 into 100. If we solve this, 12 to 100 divided by 106. So we are going to get 11.32%. Similarly, if I want to find out the percentage of oxygen, what I need to do? How many oxygen atom we have? 3. 3 into 16 divided by 106 into 100. Okay. So if we solve this, 3 into 16 into 100 divided by 106, so we get 45 plus 45.28%. Okay, so in this way we can solve the percentage of element in that particular compound. Okay, similarly you can solve for H2O, C2H5OH, Na2CO, that is urea, C6H12O6. Okay, then the last concept, that is empirical and molecular formula. So generally students used to confuse in this bit, in this two. What is empirical formula? What is molecular formula? Very simple. An empirical formula is the smallest whole number ratio of an atom in a compound, while a molecular formula shows the number of each atom in a molecule. What does it mean? It's a simplest whole number ratio. The empirical formula is just giving a simple whole number ratio but not giving the exact number of atoms present. Okay, but molecular formula shows the exact number of atoms present in that particular molecule. Okay, so see in this chart you can see water. Molecular formula of water is H2O. Empirical formula is same. Okay, because we can't consider in the ratio. If you see the ratio of H2O, how it is 2:1, and this is the simplest one. We can't reduce this ratio, so empirical formula is also same. Let me take any other color. Okay, now C6H12O6. Here this is the carbon, hydrogen and oxygen in the ratio of 6, 12 and 6, and I can reduce this ratio by dividing this 6 number, right? So if I solve this, what I am going to get? 6 2s are 6. 1:2:1. And if I write down the empirical formula, how it is? C1H2 and O1. So see, this is the same, right? Similarly, in case of hydrogen peroxide H2O2, if I see the ratio, it is 2:2, correct? And if I simplify this ratio by dividing by 2, what I am going to get? 1:1 ratio, that is HO. This is known as empirical formula. Similarly, in case of butane, C4H10. C4H10, the ratio of this is 4 and 10, correct? And if I simplify this ratio, what I have to do? By the small number I have to divide it by 4. So 4 get cancelled. 4. Okay, if we can't cancel it out, right? So what I will do? We don't need a fractions here. We don't need a decimal number. We need a whole number. So what I will do? I will divide by 2 because I can't able to divide 10 by 4, right? So 2 2s are 4, 2 5s are. So I get the simplest whole number ratio like this. This is 2:5. So C2H5. Similar in case of benzene, 6:6, and I can divide by 6 and I can get 1:1. So this is the difference between molecular formula and empirical formula. Empirical formula shows the simplest whole number ratio, but molecular formula shows the exact number of atoms present in the molecule. Okay. So what is the relationship between empirical and molecular formula? A simple relation. Here you can see what is the relationship between this. The relation between, if you take this as example, HO into somewhat number, if I multiply, I am going to get H2O2, and this number, there is a relation, right? Empirical formula into N is equal to molecular formula, right? This is the relationship I got. So the same thing I have written here. See, molecular formula is equal to N into empirical formula. This N indicates how many number we need to multiply so that I am going to get a real molecular formula. Clear? So this is a very basics which are required. Okay. So in the next coming videos, we are going to learn about other basics concepts which are very important, like structure of atom, about periodic tables and many more. So if you are new to this channel, do subscribe and share with your friend, and finally thank you.